Gaussian elimination. And by the end of today, you're going to be able to identify what's called REF and RREF, which stands for row echelon form and reduced row echelon form matrices. And we're going to solve using Gaussian elimination. And you actually already did this yesterday. We just did not put a specific name to it, so we're going to talk about a few of those things. So row echelon form is a form that we put matrices in. We can also put it in reduced row echelon form, and they're actually really helpful for picking out solutions in a matrix. So if you just have row echelon form, that's what we did yesterday. We put the matrix in triangular form so that we could use what to solve the system? Back substitution. Now we're going to learn about one called reduced row echelon form, which is really cool because if it's in reduced row echelon form, you can just look at the matrix and you'll be able to see what x equals, what y equals, and what z equals. Okay, so reduced row echelon form is going to give you your solution right away. Okay, that's what makes it fun. All right, so the first thing we have to do is identify what makes this in row echelon form. Is this on topic?
Nope.
Okay, so we hold it, please. Hey, so the matrix is in row echelon form if it satisfies the following conditions. So the first condition is that the first non-zero number in each row when you're reading it from left to right is 1. Okay, so the first non-zero number in each row is going to be 1, and then that has a special name. This is called the leading entry. Okay, which is something that we're going to talk about several times today. So this leading entry in each row has to be to the right of the leading entry in the row immediately above it. So if you're looking at the matrices, your first leading one should be to the left of the next one. Okay, they're going to go from left to right when you're looking at the matrix. And then the last thing is that if there is a row of zeros, all rows consisting entirely of zeros are at the bottom of the matrix. What do you guys think your solution is when you have a row entirely of zeros at the bottom? Think about that. We'll come back to it. Right, now, we also have reduced row echelon form. If it's in reduced row echelon form, first it has to be in row echelon form. So it has to satisfy all those three conditions above. And then the one other thing that it has to do is every number above and below each leading entry is a 0. So that's a little bit different from yesterday. Okay, yesterday we were just getting zeros below the 1. Now we're going to have them above and below. Okay? All right, so we're going to observe the matrices below and then label what form it's in, if it's in any form at all. And we're also going to highlight the leading entry in each row. So if you did all your homework last night, did you guys see there was a chunk of them that had A, B, and C? But A and B were just yes or no questions. So part of your homework is to examine these matrices, and if it's in reduced row echelon form, you'd put yes. If it's in row echelon form, you'd put yes as well. Okay, can a matrix ever be in reduced row echelon form and not be in row echelon form? No. Okay, can a matrix be in row echelon form and not be in reduced row? Yes. Okay, so if you answer yes to reduced row, you have to answer yes to row echelon form. Okay? All right, so let's highlight the leading entries here. So the leading entries are going to be your first non-zero numbers. So this would be a leading entry in our first row. Oh, and if you don't have a highlighter, if you just want to circle them. Okay, and this row, the first non-zero is here, and then the first non-zero is here. Okay, so let's go through our conditions. Is the first non-zero number in each row a 1? Yeah, this is a 1. Yep, a 1. 0, 0, 0, 1, 0, 1. Yep, so it meets condition 1. Condition 2 says the leading entry is to the right of the row immediately above it. So if we look at this row, is the next leading entry to the right of it? No, it's to the left. Okay, see how this one is to the right? So those two rows would meet that. Okay, but since these are to the left, it does not satisfy condition 2. So we're just going to write that below. So does not satisfy condition number 2, which means this is not in row echelon form, which we can call REF. All right, now let's highlight the leading ones for the next one. So here's my 1, here's my 1, here's my leading entry, and then all I have are zeros on the bottom, so I don't have a leading entry for that row. So let's check the first one. The first non-zero number in each row is 1. Yep. The leading entry in each row is to the right. Yep. This one's to the right. This one's to the right. So you're good. Notice that it doesn't have to be like directly to the right. It could be a couple spaces over and still to the right, and that's fine. And then if there is a row of zeros, it has to be at the bottom, and that's true. So this is in reduced row, row echelon form. It's not in reduced echelon form because is every number above and below the ones is 0? No. Okay, so this is only going to satisfy conditions 1 through 3. Okay, and then let's highlight our leading ones here. So here's my leading 1. This is to the right. This is to the right. Okay, so it does satisfy 1 and 2. Are the row of zeros at the bottom? Yes. Is every number above and below each one a 0? Yep, so below, these are all zeros, above and below, above and below. So then this is in reduced row echelon form. Okay, and this does satisfy conditions 1 through 4. I also just want to make a note, even if you don't have a row of all zeros, it would be in row echelon form, as long as your leading entry was to the right. Okay, so even if you didn't have this last row, that's still going to be in row echelon form. Yeah, Jason?
So, for condition number 4,
Yes.
so all of them above and below would have to be zeros? Like, it's going to be like, for the first one, like
Right, yeah, like in this one here, see how above I have the -6?
yeah.
Below I have the zeros. So that's why it would just be row echelon form and then not reduced row.
Would it still work if you skipped one and it was a 0 and then like 6 or something? Would that work?
Where are you saying the 6 would be?
Well, yeah, so right there. So if like you skipped the 0 below it and then the one after that it was a 6,
Like this one?
Yeah.
Right, nope, then it wouldn't be. Okay, so if it's row echelon form, the zeros have to be below it, and if it's reduced row, zeros above and below it, so no other numbers. But then, as you can see, like in this row, that would be fine. All right, good. So let's go to the next page. So we have some terminology here. So we can put a row in, a matrix in row echelon form by using the elementary row operations, which is what we did yesterday. There is a systematic way that we can use in order to convert a matrix into row echelon form. So we're going to go through these steps, and these steps should seem very familiar to you because it is what we did yesterday. Okay, so I'm hoping that if you did yesterday's homework, today is going to go a lot quicker for you. Because once you're first learning it, it just takes a while for you to do those processes in your head. And then, so once you practice it, you're going to get a lot quicker with it. So the first thing we do, what was our first step? You're going to start by obtaining what? Before that. What's always your first step? One where? Top left corner. So we have to get a 1 in the top left corner. Okay, and remember that's row 1, column 1. Okay, and then from there, next, that's when we're going to obtain what? The zeros. Okay, so then you're going to obtain the zeros below that 1 by adding appropriate multiples of the first row. And the reason why you want to use the first row is so you don't undo the work you've already got in position. So once you get the 1 in position, you can always do a multiple of the opposite and add them together to get 0. Okay, and then for step 3, you're going to obtain a leading 1 in the next row, and then obtain zeros below that 1. And then what just happens is you keep doing that process over and over again. Okay, so you're going to continue that process until your matrix is in row echelon form. And then I just wanted you to note that at each stage, make sure every leading entry is to the right of the leading entry in the previous row. And then you can always rearrange the rows if you need to. You can always interchange the two. Okay, you can flip them. So this is how the process is going to work for a 3x4 matrix, and this is what we talked about yesterday. Remember how I said we work down the columns? So first we'd get the 1, then we'd get the 2 zeros. Okay? Then we get this 1, and then we get this 0. Okay, so we do this first, second, third. We do this fourth, and then fifth. We do this sixth, and then we're done. Okay, and then this is going to be in row echelon form. Okay, so the process that we did yesterday and that we're going to continue to practice today is called Gaussian elimination. It is named after the inventor, C.F. Gauss, who is a German mathematician. And the next box just gives you the steps for how you would solve a system, which are the exact steps that we used yesterday. Okay, so if you're solving with Gaussian elimination, and you might have noticed that on your directions, and then hopefully you just kept going with what we did. So your first step is to put it in an augmented matrix. Your second step was put it in row echelon form, which is what we did. We just didn't know that's what it was called. And then our last thing would be to use back substitution, which is exactly what you guys did yesterday, right? Yep. Augmented matrix, and then you just didn't know it was in row echelon form, but it was, and then you're using back substitution. So we're going to solve this system using Gaussian elimination. So the first thing we're going to do is make the augmented matrix. Okay, so let's go ahead and do that. And if you write bigger, I did leave some space on the next page for you too. Okay, so like I said, sometimes it's nice to put them in columns. So 11, 7, negative 6. Remember to form the augmented matrix, we're using the what of the equations? Yeah, you're using the coefficients, right? And then your last row is the constants. Okay, so remember from yesterday, the first row represents all of the x variables. The second row represents all of what variables? The coefficients of what? Y. The third row represents coefficients of z, and then the last row is the constants. Okay, so the first thing we want to do is obtain a 1 in the top left corner. How can we do that? Okay, good. So Colin, what's the reciprocal of this? Good. And why is that going to be especially nice for us? They're all multiples of 11 in the first row, aren't they? So that's going to be really nice because we're going to have all whole numbers. So remember from yesterday, sometimes I just like to write the other two rows first. That feeling of accomplishment, knowing that we already have most of our matrix. So essentially, what I'm doing is dividing by 11. So if I divide by 11, I get 1. 22 divided by 11 is what? 2. Negative 11 divided by 11, negative 1. And 22 divided by 11 is 2. Okay, so Cam, what's my next goal? To get the 7 as a 0. Yep, okay, so we want this to be a 0. So I'm just going to circle it and say, oh, that's what I want to work on. Okay? So, Jackson, what can I do to cancel out with 7? Okay, so in order to cancel out with 7, what could I multiply the first row by? So when you add it, right, you want it to be 0. Yeah, negative 7. So you're just going to multiply by the opposite. And you can always do that with the first row because you've already got that 1. So you've already got the 1, so just multiply by the opposite, add it to row 2, and then we're going to put that in place of row 2. Okay, so I want you to go ahead and do that. Okay, it's really important that you're thinking about it instead of having me think about it and you just copy it down. Okay, so let's see how we did. So if we did -1 or -7 times row 1, then we would get 0. This was -14 plus 14, and you got 0. 7 plus 5 was 12, and then -14 minus 10 was -24. Is that what we got? Okay, so what are you guys thinking we should do next? Okay, we could do that. Yeah, why would that be a good option? Just switch 2 and 3. See how there's already 2 zeros here? And don't I need 2 zeros here at the bottom? Okay, so it would be a good idea to switch these 2 rows. Okay, you could also get the 0 here, right? That would be fine, but this is gonna help us. So when you're writing this out, just write it out left to right. And I don't care if you put like the arrow here or if you put the arrow on the next row. Just make sure that you don't snake it around, because that's gonna make my head hurt when I have to grade 100 of those. Okay, so left to right, just like you're doing a book. Okay, capiche? Okay, so I'm gonna switch row 2 and row 3. So row 1's gonna stay the same. This is gonna become 0, 0, 12, -24. This is gonna become -6, 1, 58, -51, which means now I'm gonna have to work on making this a 0. So I'm gonna use that same strategy I did before. I'm just gonna multiply the first row by the opposite. Okay, so Josh, can you tell me what I'm gonna do? What's my rule gonna be?
It's going to be 6 times row 1.
Yep.
Plus row 2.
Good.
And then substitute it in row 2.
Perfect. Okay, so because we're substituting in for row 2, I'm gonna keep my row 1 and row 3. Okay, so then if I multiply by 6 plus -6, I get 0. 6 times 2 is 12. 12 plus 1 is 13. When I multiply by 6, I get -6. -6 plus 58. Okay, and then for this one, 6 times 2 is 12. When you add that to -51, because remember you're doing this without a calculator, you can add 10 first, which will give you what? If you add 10, what do you get? 41, and then just add 2 to that, and what do you get? -39. Okay, so now I have 1, 0, 0. I need this to be a 1. What should I do? Whenever you want this to be a 1, multiply by the reciprocal, right? So this will be 1/13 times R2. So I have 1, 2, -1, 2, 0, 0, 12, -24. And this is actually nice. Does 13 go into 52? What's 13 plus 13? 26. What's 26 plus 26? 52. So how many times does 13 go into 52? 4 times. And how many times does it go into -39? -3. Okay, so now I have to make this a 1. And in order to do that, again, I can multiply by the reciprocal. And this is a nice one because every single time we've multiplied by the reciprocal, we've gotten all whole numbers. Isn't that nice? Enjoy it while it lasts. Okay, now that I have this, see how I have 1, 0, 0, 1, 0, 1? I have this diagonal of 1s, and then I have the zeros below them. This is in row echelon form. Okay, so now we're going to use back substitution. Okay, so we're going to use back substitution to solve. Okay, and I'm going to do that on the next page since I gave you a whole chunk of space. So to do that, we're going to write out the equations. Okay, we're going to start with this equation here. The bottom equation. Remember how I told you the first row represents the coefficients of what? Of x. Okay, Caden, what does the second row represent? What does the second row represent? The coefficients of y. Henry, what does the third row represent? The coefficients of z. And then JC, what does the last row represent? It's just going to be your constant numbers. Okay, so whatever your constant numbers are. Okay, so Cheyenne, look at this last one with me. What does this mean as a linear equation? If I have 0, 0, 1, negative 2. Good, okay, so that's where I'm going to start on my next page. Okay, so my system would be z equals negative 2. Okay, now I'm going to write this equation. Okay, so then Aiden, will you tell me what this equation is going to be?
Second one is y plus 4 times -2.
It'll be, oh, yeah, sorry. I'm going to write it out with variables first.
For z equals -2.
Good. Okay, and then Liam, what's my top equation?
X plus 2y minus
Keep going.
equals 2.
Good. Okay, so now that I have these three equations, I can use my back substitution. Okay, so I can plug in my negative 2, which is going to be negative 8. So when I add 8 to both sides, my y value is going to be 5. And then here, now that I know my y is 5, be careful with your minus and negative here. So you have 10 plus 2 equals 2, or x plus 12 equals 2. So when you subtract 12, what do you get? Negative 10. Right? Now when you have this on your test, you're going to know before you turn this in whether or not it's correct or not, because you can always do what? Yeah, you can always plug it back into the original to make sure that that satisfies every one of those equations. Okay, so continuing, if we put the augmented matrix in reduced row echelon form, then we don't have to do back substitution. Okay? Then we're just going to be able to look at the matrix and see what each variable is. So to obtain reduced row echelon form, we have to first put the matrix in row echelon form, which is what we just did up here. Then you're going to obtain your zeros above each leading entry by adding multiples of the row containing that entry to the rows above it. Okay, so we're going to go over what that looks like. So you're going to begin with the last leading entry and you can work up. And then when you're solving a system that's in reduced row echelon form, that is called Gauss-Jordan elimination. So they're sharing the credit for that. Okay, at the final step, your matrix should look like this. This is in reduced row echelon form. And then let's look at what equations this would produce. So the first equation, see how you only have a 1 for the x? And then you don't have any other variables? This is just going to tell you x equals whatever number you have in your last column. Okay? This row only has a 1 for y, so you're going to get y is equal to that number in the last column. And then the third one is just going to give you z is equal to that number. So it's going to be very simple to pick out what your solution is. So what we're going to do is we're going to take that matrix from example 1 and continue the process to put it in reduced row echelon form. Okay, so we're going to take the matrix from example 1 and then we're going to continue to put it into reduced row echelon form. So let's look back to our I always say reduced row. Let's look back to our row echelon form matrix, which I have right here. Okay, so I'm just going to write that matrix. So we had 1, 0, 0, 2, 1, 0, negative 1, 4, 1, and then 2, negative 3, negative 2. Okay, does that look right? Did I write it down correctly? Okay, so now we're going to start to obtain those zeros above. So the first thing I want to do is make this into a 0. Now when you're deciding how you want to make that into a 0, see how this row already has that leading 1 right underneath it? So we're going to want to multiply this row by the opposite. So the opposite of 2 is what? Negative 2. So I'm going to multiply row 2 by negative 2, add it to row 1, and then put that in as my new row 1. The reason why you always want to do this one is see how this is 0? So when you add 0 to something, it's not going to change it. It's going to stay the same. Right, so my bottom 2 rows are going to stay the same. Okay, so now I'm going to do negative 2 times 0 plus 1, which will be 1. Negative 2 plus 2 will be 0. Okay, do these with me. So when you multiply by negative 2, what do you get? Negative 8. Negative 8 plus negative 1 is negative 9. Okay, for this one, you're going to multiply, and what do you get when you multiply? 6, and then 6 plus 2 is 8. Okay, nice. Now, what's the next thing we want to do? So we have 1, 0, 0, 0, 1, 0. These 2 rows are good. What do we need in this row? We need zeros above the 1, right? Okay, so let's make this into a 0. Okay, I want to multiply by the opposite and then add it here, because see how now I have these 2 zeros? Right? And this one has your leading 1. So the opposite of negative 9 is what? 9. So I'm going to multiply row 3 by 9. I'm going to add it to row 1, and then I'm going to replace row 1. Okay, which means my bottom 2 rows are staying the same. So I can put those in first. And now I can start to do my calculations. So the first ones are pretty nice because I'm just multiplying by 0, and then so I'd add 1, multiply by 0 plus 0. 9 plus negative 9 is going to be 0, and then I have to do some work. So 9 times negative 2 is? 9 times negative 2 is? Thank you. Okay, and then so negative 18 plus 8? Negative 10. Thank you, Henry. Okay, and then Nick, what's our next goal? So after we get this 0, what do we want to get next? Yes, so we want to make the 4 into a 0. Okay, so Kim, what am I going to do to make that 4 into a 0? Good.
plus R2,
Good.
and then you replace it with the R2.
Good. Okay, so then let's do that. Good plan. So I'm replacing R2, so this is going to be 1, 0, 0, negative 10. And then the last row is 0, 0, 1, negative 2. Okay, so if I multiply 0 by anything plus 0, I get 0. 0 plus 1 is going to be 1. Negative 4 plus 4 is going to be 0. And then I get to do some calculations. So negative 4 times negative 2 is what? 8. 8 plus negative 3 is 5. And then this is in reduced row echelon form. Okay, so from reduced row echelon form, this top equation is telling me that x is equal to negative 10. This is telling me that y is equal to 5, and this is saying that z is equal to negative 2. Is that what we got for our solution? Yep. Okay, so there's also a function on your calculator that's going to put matrices in row echelon form or reduced row. I said maybe if you're nice, I'll share it with you so you can check your work quickly. But then I also need to remind you that you will have a Chapter 10 test in which you will not be able to use a calculator to do these types of problems. So you have to use your calculator functions responsibly. Okay, so you will not be able to use your calculator. Okay, but it is a good thing to know so you can check. Okay, especially if you're getting stuck. Because a lot of times it's just a small arithmetic mistake, and I know that can be frustrating. Okay, so we'll go over the last page, which is really just information, and then I'll show you how you can use your graphing calculator to put your matrix in the proper form. Okay, so this is going to be a review of inconsistent and dependent systems. So the systems we've been working with just over the past couple of days, they all had exactly one solution. But as we know, a solution or a system could have one solution, yep, no solution, or infinitely many. Okay, so the row echelon form of a system allows us to determine which of these cases applies, and they describe what it's going to look like in the following box. Okay, so if there is no solution, so we did this with our linear equations, just not in matrix form, you're going to have some statement where 0 is equal to a constant. And remember, that statement is not true. So if you have that, then the system is called inconsistent. Okay, and then I'll show you what that looks like when you see it in a matrix. If you have one solution, that's going to be exactly like the matrices that we solved today and yesterday. So if you have a leading variable, then there's going to be exactly one solution. Okay, so if each one has a leading variable, then you're good. And then the last one is going to be infinitely many solutions, which is a dependent system. So if you have infinitely many solutions, remember how we saw earlier that some matrices had a row of all zeros at the bottom? Okay, so if you have a row of all zeros, the equation that's creating is 0 equals 0, which is a true statement, and that's how you'll know when there are infinitely many solutions. Now, the way that they say it here is if you don't have all leading variables, okay? And then if it's not inconsistent, because it would not be 0 equals C, it would be 0 equals 0. Okay, so that's kind of wordy, but basically you're not going to have leading variables. Okay, so you won't have like a leading 1 in your system. So when they're talking about leading variables, we're going to talk about that terminology. A leading variable in a linear system is one that corresponds to a leading entry in the row echelon form of the augmented matrix. So the matrices below, they are all in row echelon form. They're going to illustrate these three cases, and we're going to label each one with the type of solution it portrays. Okay, so if we look at this matrix, we have these leading ones, and then look at the last row. If I have zeros in these first three spaces, what does that mean? If you have 0, 0, 0. Well, there'd be no variables, right? There's no x, there's no y, there's no z. Okay, so it would be 0 is equal to 1, which, is that a true solution? Is that a true statement? No, 0 doesn't equal 1, so this type of matrix would represent no solution. Okay, and then what we would say is that it's inconsistent. So if you look at some of the directions, it'll say, identify if it's inconsistent, and if it's not, find the solution. Okay, so if it is inconsistent, we would just write that down. Now here, you have a leading variable for each one, right? The bottom one here would be z equals 8, and you could use what to solve this system? What method could you use to solve this one? Back substitution. So this is going to have one solution. And then the last one, if you have a row of all zeros, what that means is 0 equals 0, which is a true statement, but there's no leading variable. So that's when you're going to have infinitely many solutions. And if you have infinitely many solutions, you would say that the system is dependent. Alright, so if you did not finish your homework from yesterday, make sure you do that this weekend. And then from your same section, 10.3, you're going to do 11 through 18, but just parts A and B only. So yesterday you did some of the part C. Okay, parts A and B are just going to ask you if it's row echelon form or reduced row echelon form. Okay, so you're not going to have work. Your work is going to be in your head. So you have to examine the matrix and see if it's in the proper form. Okay, and then you'd write yes or no. So those are like yes or no. And then you'll have some where you're going to practice your, this is 21 through 23. I'll just put 21, 22, 23. And then 36, 38, 39. It's the same page as yesterday. Do you guys remember what page it was on yesterday? Okay, so have both of those homeworks done for Monday. If you